Hey everyone, Mr. Anderson back with you again to talk today about section 9.3.1 from our CPM Common Core Algebra book. Today we're going to look at graphing inequalities in two variables and what that looks like. And to just give you a quick reminder where we are in chapter 9. We've hopefully checked out all the videos from 9.1 and 9.2, and we're going to start talking about the stuff from 9.3. And as always, I've got some modified notes, but we really are going to examine, like I said, graphing inequalities in two variables today. And one of the things I'm not going to go over just for sake of time in this video is graphing specifically the types of solutions in a linear equation. And what I mean by that is we'll talk about how to graph a line, of course, because that's a necessary skill. But the recall that all of the points on a line are values that make that equation true for x and y. Okay, that's what a line is, right? It's that graphical representation of all the points put together, and they make a line because there's infinitely many of them that make that equation true, right? So we're going to need that knowledge, and we're going to move into problem 9-66 here with that knowledge. And if you're someone who's scratching your head as you hear me talk about that and you're going, gosh, I don't remember some of that stuff, you maybe are going to want to go back and check out some earlier videos that we have as part of this package, and you can see those things and hopefully give yourself a quick refresher back from some of our earlier units in like chapter 2 and 3. Okay, but here we go. We're in 966, and we're going to graph and specifically talk about this particular inequality. Is y is greater than or equal to negative 2x plus 3. Here I am with my modified notes as always. We will need knowledge of the equation. We're going to need knowledge that this thing right here in slope-intercept form is the slope. This thing right here is the y-intercept. Those two things are really going to be useful for us, okay? And what we're going to do to get started is, as we did in 9.2, we're going to test points, right? Like for the purposes of figuring out if they make our inequality true or not true. And what we're going to go ahead and do here is I've got 3 points that I've selected, and we're going to test them all in our inequality. And the way we do that is identifying that our ordered pairs come in XY coordinate format, right? So the x comes first, the y comes second. We're just going to plug these things in, and we're going to do a little checking. So I'm going to start here, and I'm asking the question, is y, 0, greater than or equal to negative 2 times 0 plus 3? Okay, and this works out really pretty nicely. 0 greater than or equal to negative 2 times 0 is 0, and 0 plus 3 is 3. Is y greater than or equal to 3? And the answer to that is, no, it's not. Okay, that's false, right? And I'll maybe just make a little note there, false. Okay, I can do the exact same thing over here, except now I'm going to plug in 0. Is that greater than or equal to negative 2 times, whoops, look at this, I said it right, but now I'm plugging them in backwards. 3, is that greater than or equal to negative, let's see, 2 times 0, negative 2 times 0 plus 3. And I'm using that inequality, right? I'm using this guy to plug the points into there. So, okay, 3, is that greater than, let's see, negative 2 times 0 is 0, right? Is that greater than or equal to 3? And the answer, because this is a greater than or equal to case, that's true. So I'm just going to make a little note that up there is true. And then one more time, 2 is my y. Is that, I'm asking, greater than or equal to negative 2 times 4, and then plus 3. Okay. Negative 2 times 4 is negative 8. Negative 8 plus 3 is negative 5. So 2, is that greater than or equal to negative 5? And the answer to that is yes, it is. So we've identified another true scenario. Now, the reason I did these, the reason I picked these points, I picked these ones, by the way, is because they're going to become valuable when we go to do some testing here. So what we're going to do is we're going to take this line, and we're going to do some graphing, and we're going to use these points to help us identify where our solutions lay. So the first thing I'm going to do, I'll remind you of our inequality, and I'm going to remind you that my y-intercept is negative 3. I like to start there when I'm doing my graphing. So just on the y-axis, I'm going to make a dot at positive 3, sorry. And then my slope is negative 2. So that's, of course, negative 2 over 1. All right? So I'm going to go from there down 2 and over 1. And I'll continue to go down 2 and over 1. I just like to, get as many points on there as I can. And then I can even go up 2 and back 1, right? And again, if some of the stuff I'm doing here, you're like, gosh, what is he doing? Right? Go ahead and watch some videos that we've got posted from chapters 2 and 3, because those things are going to help you with some recall here. But now, for our sake, trust me that I'm going to make a solid line. I'm going to explain this later, all right, in a little bit more detail. But there's my solid line. And then we had 3 points. I had the point, and I'll use a different color for these. I had the point 0, 0. I had the point 0, 3. And I had the point 4, 2. Okay? These 2 points over here, these 2 points were my true points. These 2 points were this 1 point, sorry, this was my point that was false. This made my inequality false. Okay? And when we have an inequality, we shade, just like you do on a two-dimensional number line, I guess it's one-dimensional, you're left, right. We've got to shade here, and we shade toward the truth, but instead of just acting as a dot as my boundary, now I have like a fence as my boundary, and I'm going to shade everything over here that makes it true, and there's x's and y's that make this thing true. So I'll shade all of these things. So this is what this looks like, and this is why we need to check those points. All right, just shade it in real quick. All right, and there you go. And so in an inequality, we're going to be looking for, when graphing an inequality, that you have an accurate line, that you have the right kind of line, and I'll describe that more in a second, and then, of course, the appropriate shaded region. And we can continue to do that down here. I've got a couple more examples here, and I'm going to go a little bit more quickly, but I definitely want to tackle A, because A is a different type of line, and I want to focus in on this dot right here, this bullet. Graph it as solid or dash. Check this out. If I'm going to graph A, I'm going to start the exact same way. I'm going to use blue here for this one. Don't know why, I just feel like blue. -1 is my y-intercept, and then my slope is -1/3, so I go down 1 and over 3, down 1 and over 3, and I can even go up 1 and back 3 for accuracy. And now it's time for that line. This way. We'll continue it this way as well. Ta-da! Okay, so there's my line. Now, you're looking at my line, you're going, okay, you made a solid line. Now watch this. Okay? I'm going to test 3 points one more time. I'm going to test 0, 0. I really like testing 0, 0. I'm going to test the point, how about -3, 0, right? It's on my line. I, need to do that. And then how about 0, -3, okay? And let's just do a little quick mental math, all right? Do a little quick mental math. If I plug in 0, 0, if I plug in 0 for this and 0 for this, is 0 bigger than, the x cancels out, is it bigger than -1? And the answer is yeah, cha-ching, this is a true statement, okay? Let's go ahead and plug in, I don't know, 0, -3, so 0 there, -3. Again, this is going to cancel out when I plug in 0 for that. So what we're asking is -3 bigger than -1? And the answer is So this is going to make it false. Okay, so I already know I'm going to shade toward the true. So I'm thinking I'm going to shade up here, right, on this side of that boundary. But let's check one more. All right, let's check -3, 0. So I put in -3 there. I plug in 0 there. 1/3 times -3 is, I'm sorry, -1/3 times -3 is +1. So this is going to turn into a 1, and we have 1 minus 1, right? Is 0 bigger than 1 minus 1, which is 0? Is 0 bigger than, not bigger than or equal to, but bigger than? That makes this point false as well. Okay, so now check this out. All right, I'm going to get rid of this. We definitely know we're going to shade toward the truth. I'll make my highlighter bigger so my shading is a little bit more efficient. But how do I make it clear that I'm not intending to have that point on the line be a solution? And we go like this, folks. All right, we go like this. I got rid of my line. I got rid of my solid line. If I want to poke holes in my line, literally, make it clear that it's not a solution, we dash our line. And we do so with the case where we're dealing with the less than or greater than. Now I realize my shading got a little sloppy there, and I'm hoping you're going to forgive me, right? I shouldn't be shading over that line, but for the purposes of time, I'm going to leave that way. Okay? I'm going to go a little bit more quickly through these next few just for a little bit of practice, right? I've got a point at 2 that I can graph very easily. It's my y-intercept in this one. Y is less than or equal to 4x plus 2. And then a slope of 4 over 1. So I can go up 1, 2, 3, 4. I can go over 1. I can go down 1, 2, 3, 4. I can go back 1. I can continue that. And there I've got enough information for my line. This right here says solid line. So I know I'm going to be making that line nice and solid, not dashed. And I'll try quickly to draw that. All right. Go ahead. And now we just got to test. And I really like testing 0, 0 because 0 really makes my math nice and easy. Now watch how I'm going to do this here. I'm going to plug in 0, 0. I'm going to put in a 0 for here and a 0 for there. And it's going to be 0 is less than or equal to 4 times 0 is 0, and 0 plus 2 is 2. Hey, cha-ching, that is true. Well, guess how inequalities work? If on this side of the line is true, what do you suppose happens over here? Well, it's got to be false. And now I'm dealing with a situation where I can just shade on one side of the line after testing 0, 0. Because 0, 0 is a really, really nice point to test. Okay, so I can quickly tackle a problem like that. Let me do one more of these things, but let me tackle one that's not in slope-intercept form. Let's review standard form real quick, like in letter D. Okay, letter D, I'll invite you to recall we can use this intercept method for graphing. You can convert this to slope-intercept form; it won't be too bad. But if we recall that we plug in 0 for y, we can solve for x real fast, and we can say, well, x has got to be 2.5, right? That means my x-intercept is going to be right here in between 2 and 3. Now I can do the exact same thing. I can plug in 0 for x, and then I can say, okay, negative y is 5, so positive y has got to be negative 5. And now I have those 2 points that'll help me make my line. Okay, now check it out real fast. I've got a less than or equal to scenario. So that means my line is going to be solid. So I'll just, if I had a ruler, I guess I'd line up my ruler here. But I'll do my best to make sure that I'm trying to connect both of those 2 points. And I did an okay job there. All right. But there we go. And now it's like, which side do I shade? Well, one more time, I'm going to test 0, 0. And this is why standard form kind of rules. Because if you're in standard form and you plug in 0 and 0, what does that whole side turn to, right? That whole side turns into 0, and is 0 less than or equal to 5? That is a super easy inequality to evaluate. And of course, 0 is less than or equal to 5, so that makes this thing over here true. That's a true point. And now, folks, we just shade toward the truth, right? If that is true, everything on the other side is going to be false. It's going to make our inequality false, so I'll just shade over here toward the truth. Okay, ladies and gents, as I complete the shading here, that's going to kind of wrap it, right? I realize I didn't do letter C, but maybe you can challenge yourself with letter C there, okay? Right down here, we've got a little bit of review preview here. And this review preview is not designed to take up all of your time. It's designed to flush out questions that maybe you don't even know you have yet. So give these things a shot. Don't be afraid to ask those questions. Ladies and gentlemen, thank you for watching. Have a great day.